To completely simplify a radical expression, rationalize the denominator so that no denominator is a radical expression. Let's try solving the following. And do notice, in this case we're doing square roots, in other words, rational expressions. And we gotta rationalize the denominator, meaning we gotta make it an exact denominator, exact value, rather than an approximate continuous value, okay? So once again, rationalize the denominator for the end results. We may not have to do it for all answers necessary, but let's start with the first one, A. On A, we have 3x squared minus 5 equals 6. And we're going to get rid of the 5 to solve for x. Keep in mind, we're going to try to keep it very, very simple as possible. So adding 5 to both sides, we'll get rid of the 5 to solve for x. Agreed? 6 plus 5 gives us 11. That leaves us with 3x squared on the other side. Now let's get rid of the 3 from the x squared. Divided by 3 on both sides, right? So 11 divided by 3 will give us a decimal. We want to try to go for an exact answer in this case. That way we can see what rationalizing the denominator will look like for us. Agreed? So let's cancel our 3. And that gives us that x squared equals 11. So we want to get rid of the x squared. Okay, let's not forget our divided by 3. And square root on both sides. That will get rid of our square. Square root is the opposite of a square, okay? Agreed? Alright, so in this case, I want to distribute or separate out my radical sign, my square root sign, meaning I want to do square root on top and square root on the bottom. Since it's pure multiplication and division, this works. Otherwise, if I was adding or subtracting, it wouldn't work. So square root of 11 over the square root of 3, it works. But now we want to rationalize the denominator, meaning the square root of 3 will give us a decimal number that's continuous. We don't want a continuous decimal number. Instead, we want an exact value. So what we're going to do is multiply by the square root of 3 that's on the bottom. And we're going to do it to the top as well. This will make it so that we're technically multiplying by 1. But it's because it's square root of 3 divided by square root of 3 gives you 1. And that's to make the bottom be an exact number, in other words, 3. So, reference note, notice that if we have square root of 3 times the square root of 3, it becomes essentially like saying 3 squared or the square root of 3 squared. So they're equals in opposite. So the square root and the square cancel out, leaving us with the 3. This is for the denominator, okay? But we have to do square root of 3 on the top also, right? Because otherwise we're changing the value. So once again, that gives us 3. And this is what we call a rational number now because it's an exact number. So now, square root of 3 times square root of 3 in the denominator cancel out, giving us just a 3. So we have on the top, 11 times 3 gives us 33. And we're combining to a single radical, single square root of 33 over 3. Let's remember to have a plus or minus added to that. Since we cannot simplify, 11 is a prime number, 3 is a prime number, so there is no way to simplify the square root of 33 other than by giving a decimal approximation. We don't want a decimal approximation, so we'll call this our final answer in exact value. Otherwise, if you want to try this as an approximate decimal, I'm pretty sure you can plug it into your calculator, right? Keep in mind, you're separating this into 2. If you want to try them separately, square root of 33 divided by 3. And x equals negative square root of 33 divided by 3, which should give you essentially the same number, but one positive and one negative. Agreed? Real quick heads up for your calculator. And let me turn it on. Turning on the calculator. And once again, real quick. If I hit second, x squared will give me the square root button, so x squared. And I want to put 33, close my parentheses. And now divided by 3, hit enter. And that should give you your approximate decimal value. It's 1.91, and we can add a plus or minus because your calculator will only give you the positive value. Agreed? So adding the plus or minus, there we go. X equals plus or minus 1.91 if we want to give us an approximate decimal value. But otherwise, we've already circled our final answer, which is in exact form, exact value form, I should say. Okay, let's go for the next example, B. B. In this case, we have in parentheses p minus 2/5 And then outside the parentheses, we have a square. On the other side of our equal sign, we have 17/25 or 17 divided by 25. Now, the first thing I've noticed in many cases, what we have a tendency to want to do is we may have seen distribution of exponents. And that means we want to distribute the 2 to the 2/5 and to the p, but do notice there is a subtraction. Here's what I mean. Trying to distribute the 2 into the 2/5 and distribute to the p. We don't want to do that because there is a subtraction. We are not able to do it. So can't do it. Be aware of that. Do not expand. We can't expand in this format. We can expand through multiplying two sets of parentheses that look the same, right? But then we're going to end up with a really complex equation. We don't want to do that either because that's going to give us a lot of work. So instead, let's go to the best route solution. So let's rewrite everything just for reference, that way we can see it a little bit more cleanly. We have in the parentheses p minus 2/5 outside the parentheses, the square. Let's get rid of the square because that's the easiest thing to get rid of in this case. So the opposite of a square, square root, agreed? And we do the same thing on the other side of the equal sign, square root of everything on the other side. So square root of 17 over 25. On the left side, square root of p minus 2/5 square will cancel out. There we go, it cancels out. That leaves us with p minus 2/5 without parentheses now. There we go. On the right side, square root of 17, we can individualize the radicands over square root of 25. Square root of 17 is a prime number, so we can't take the square root. 25, on the other hand, square root of 25, one number times itself gives us 25. Did you say 5? 5 times 5 is 25, right? Okay. So therefore, we have square root of 17 over 5. Let's remember the plus or minus added to that because it is a square root. And now let's get rid of the negative 2/5. So get rid of the 2/5. Look, that should have been a plus 2/5, right? I'll come back and update my signs in a minute. So negative 2/5 to both sides. It should have been a plus 2/5 to both sides. And then I'll typically add the square root portion to the backside to make it easier to visualize. This is typically how we leave radical expressions, with the ones that don't have a radical in the front, numbers with radicals in the back or on the right side. So if p equals, and I need to update that negative sign to be positive, 2/5 plus or minus the square root of 17 over 5. Since they both have a denominator of 5, that should technically be all divided by 5. So p equals negative 2 plus or minus 17 divided by 5. Let me not forget my square root. And that will technically be my final answer solution other than me updating my signs correctly. So technically this should have been a positive. Likewise up here, this should have been a positive value. There we go. And here I should have been adding instead of subtracting. Agreed? So there we go now. That is my exact value solution. I'll leave it up to you if you want to give your approximate decimal solution, but keep in mind, you split this up into two equations, one where you say 2 plus square root of 17 divided by 5, and the other one you say 2 minus square root of 17 over 5. And you're going to end up with two solutions.